Good evening, good afternoon, and good morning to you all, depending on wherever you are joining from on the globe. We are here because I can see already that there are people from at least one comment I saw from Korea. There are probably some of you from on the other side of the globe, South America as well. We are here for an exciting talk on Excel to evidence and how evidence fits into policy making. Dr. Tarun Arora is our esteemed speaker today. Dr. Tarun Arora is an associate professor at Jindal School of Government and Public Policy. He is a leading scholar in India in the area of urban governance and urban development. He has earlier worked at Janagraha Center for Citizenship and Democracy, where he led India's largest urban governance project in collaboration with Brown University. Now, without data, there is no way to understand the special needs of urban sector and urban development. And Professor Arora is an expert par excellence in using data as evidence for public policy making in that area. We could not have had a better speaker for today's session than Professor Arora. So, Tarun, without any more ado, over to you.
Thank you so much, Professor Kishanu, for this warm introduction. And I just welcome all the guests from across the globe who joined in on a Friday evening. I mean, wherever you are, this really tells that people are excited about policy in general and data, and they really want to understand what's happening with policy space, especially in the global south. Uh, what we can do is, I can just have kept a timer. What I'm going to do is, I'm going to have a content which I'm going to present for about 20 minutes. Then I'll really show you some exercises on Excel, what I generally use it for. And whenever you people have questions, you can just put it on chat, and Professor Krishanu and I will address them probably during the content presentation or in the end. Right. So thank you so much, and let's begin. Uh, all right. So here we are. Uh, Professor Krishanu, just give me a thumbs up if you can see my slides. Thank you so much. All right, so the title that we kept for today's presentation is From Excel to Evidence. So what policy analysis really demands today. Okay, the policy, as we people say, it's a buzzword, right? We live in the age of dashboards. And I say this is very, very important because I recently went to Bhopal and I said went to one of those helpline numbers and I could only see dashboards. In India, there's a mission or a policy we call Smart Cities Mission. And when you go to those smart city offices, they're only dashboards, which means that they're only data. People are talking about data, people are working on data, people believe that data informs policy, right? And that's the reason data is something which is indispensable in these days. People are believe that without data, there will be no good policy making. But at the same time, the critical question is, but are we living in the age of good evidence, right? The point is that data doesn't necessarily lead to good evidence, right?
Tarun,
Of course, yes, Professor Vishanu.
just hold on 1 minute. There
Yes.
was one comment who said that he could not see the presentation. So for everybody, are you
Mhm.
guys able to see the PPT?
Yeah, just give a thumbs up on the chat if you can.
Okay, so it looks like most of the people can. So sorry to interrupt you. Please continue. It
All
looks
right,
like most
thank
of the
you.
people.
Thank you so much, Krishanu. Right. So sometimes it happens that we have enough data, right? And especially in urban, since I work in urban cities, we do have a lot of data. But do we trust that data? Can we trust that data? Really, I don't think so. Right? Cities are expanding. People are moving in cities. People are leaving cities. There's a lot of migration happening. The problem is that the consistency of data, the number of times that we collect data, leads to a problem which we call evidence quality. Right? When we use that data to produce evidence, the evidence is not trustworthy. Right? We do have a lot of spreadsheets. People have a lot of spreadsheets. We make data spreadsheets, but does it really necessarily lead to better decisions? I don't really think so. Right? Uh, what happens is when we make policies, right, we make a lot of errors, but it's not necessarily that we make errors only after when the policy has been implemented. We make these errors before the policy analysis is even done, right? And let's understand how. Okay, what does the policy analysis today demand? Since most of you are policy professionals in your own respective spaces and domain, what policy analysis typically demands five things. Okay, it requires that we need to have at least something called measurement clarity. When we do policy analysis, we do have our indicators, which are concepts operationalized into indicators, right? What we really need is how we actually operationalize those indicators into concepts or variables, right? That clarity we need to have. That's really, really important. And what we also need is how, when we have this policy which is implemented, how does distribution of these policies happen to across different economic segments, different demographic groups. At the same time, when we implement the policy, there's a huge element of finances, right? When we implement the policy, does the finance support the policy? So we also need to understand fiscal realism behind that. Does this really support the policy that we are? Is it just a populist policy without even taking care of fiscal realism? It doesn't really work. And also at the same time, when people are the target audience, they should also understand that they should be able to track, right, in a real time, whether the policy implementation is really reaching the target audience or not. So that's the reason we need to understand where the transparency is coming from. So at the same time, we also understand that entire policy analysis depends on something called methodological integrity. We need to make sure that this really, really is there. So it's policy analysis is not just about making some regressions between dependent and independent variables. It's actually much more than that. And that's the reason we chose this word purposefully. We call it Excel to evidence. And that's the reason a lot of this work, a lot of people who are working in practitioner spaces, they will understand that a lot of this policy analysis work happens on this a very basic software called MS Excel. We don't really need something which is fancy. Trust me, all these things work on Excel. We do our preliminary analysis of any policy implementation on Excel, right? So if you really have to just give an understanding of what we do, Excel is a data cleaning engine. I've been using this for about 10 years, right? I'm not even saying that when you go to advanced software like Stata and all that. Just sticks to Stata because data, you can just use this for data cleaning. It's a data cleaning engine. Okay. A lot of times when you want to classify your data into different segments, demographic groups, male, female, poor, not so poor, right? Even into education backgrounds, right? In regions, you can actually do that. You're just simply using Excel. It's a classification system, right? And at the same time, you also can work on your budget simple using a simple Excel spreadsheet. When you are using a policy analysis, when you're about to implement a policy, you need to have a backend of understanding where the budget is being used. So you just using basic simple spreadsheets of Excel, you can use that as well. So that's why Excel is a budgeting simulator as well. And most importantly, when you have a policy implementation, you also need to do something called monitoring and evaluation of that policy, right? So at the same time, Excel can be used as a monitoring dashboard. Whether particular, for example, in India, there's a very popular scheme called midday meal scheme, where just to avoid or just to reduce the student dropouts in schools, we offer a nutritional program called midday meals to school kids, right? But just to ensure that the minimum level of nutrition is achieved, how many meals have to be given? All the activities in a theory of change, each and every activity can be monitored in an Excel dashboard because I've done that. It's very, very simple, right? But to top them all, I think I generally use Excel for as a sampling dashboard. So whenever you implement policy or when you have implemented and you want to really evaluate the impact of that policy, you need to pick people to understand and split them into target and control groups to understand whether the policy is reaching the target audience or not, or whether it is really creating the impact on the ground. And that's the reason why I heavily use Excel as a sampling architecture. So my presentation most likely will be focused on something called a sampling as a technique used on Excel. Now, what's the conceptual flow? Okay, what's the policy workflow looks like? You generally start with the raw data set. I call them raw lists. Okay, when you have a raw data which doesn't make any sense, right? But you need to give some method to madness in terms of data. You create this data and apply those column headings and everything and make it little structured. Okay. When you make it a little structured, you create certain indicators. For example, you have an indicator on water, you have an indicator on sanitation, you have an indicator on, road infrastructure and all that. You can actually create a indicator on something called basic service delivery in India and add these three indicators and create a basic service delivery index. And once you've created those indicators, which are probably could be in the form of index, you can use them to create something called evidence. right? Once you've done, okay, once you have applied your impact evaluation or experimental research strategies, you can see whether this really there's an evidence for this policy to work, a policy has worked or not. And when you have collected that evidence, you can actually make a decision based on whether we should be scaling this policy further or should be stopping right there, or probably go back and visit our theory of change again, right? So generally what happens are administrative data sets are messy. Okay, they're very, very messy, right? When you create those indicators, right? When you create those indicators and then you do rank time, like for example, you have different states, you want to rank them based on those indicators, and then you make a decision whether this particular state should get more funded or this state should get less funding or something like that. Then you make those decisions, whether these decisions are justified or not. All these things are based on the first thing that I talked about, whether your raw data is clean or something which is usable or not. Okay. The entire analysis that you people do, which is the policy workflow, can actually fail if your raw data, which is the raw list itself, is flawed, right? So that can happen. That absolutely can happen, right? So when you look at a policy data set, all of you, I think it's something that whenever you look at a policy data set, there are three hidden things that you need to watch out for. When you look at that, first is who is represented. Okay, when you look at that data set, who is represented in that data set? Like, for example, when you pick people, what kind of people are represented in that sample? Okay. Number two, who is missing? If there are certain people that you should have taken are probably missing in the entire selection of data or selection of people, then it's a huge, huge error on our part, right? And most importantly, who counts? Who are the people who really, really count for that policy? Okay. So it's not a statistical question, it is the governance question, right? And which bring us the most underestimated stage of policy analysis, which is sampling. Okay. When you people do policy analysis, when you've implemented a policy on the ground, remember that when you want to evaluate the impact of that policy, before you even do something called index construction, before you run your fancy regressions, before you do impact evaluations, before you do dashboarding in terms of classification of data into subgroups and all that, you really need to understand how you create your sampling frames, right? What is your sampling logic? When I say sampling frame, is that you divide the entire area into smaller geographical units where you pick people randomly eventually, right? How do you create your sampling frames? If the sampling frames are not robust, you can't even claim that your data is robust, right? Your data is representative. So all these things are very, very important to understand, right? So if the sampling is weak, everything built after it is fragile. Understand that. Okay, so really, really need to zero down on this particular word called sampling. But the question is how Excel becomes a sampling laboratory. So there are multiple uses of Excel, but I'm just going when it comes to policy analysis. You generally, when you talk about impact evaluation, you need to really should be able to sample. All your fancy RCTs called randomized controlled trials are based on how effectively you can randomize people. Okay. And trust me, Excel is one of the best software that you can use for that. Okay. I've been using Excel to create sampling frames. I've been using Excel to remove duplicates. I've been able to do stratified sampling by caste, ward, income, region, all that. And most importantly, generate random selection. When I say random selection, what do we understand by random selection? It means that every person in that sample, in that population, has an equal chance of getting selected. How do you ensure that people have been selected without any bias? How does we allow or remove the human element from it and let the machine do the talking so that there's absolutely no bias involved in picking up our people for the sample, right? And this important thing is that Excel operationalizes this probability for us. We really don't have to work on it. Excel does that job for us. It ensures that each and every person in the population has been given an equal chance of getting selected, with me just coming and just using a single command for that. That's how it is, right? So what are the types of sampling that we can do in Excel? Uh, Professor, can you just keep me alert on timing? So I just have about 5 more minutes of the presentation and then move to Excel right there.
Okay.
Yeah. So what type of sampling that we can do in Excel? Simple random sampling, we can do stratified sampling. I'm not going into these concepts because this is going to be in a separate webinar altogether, right? Sometimes we can do proportional to size sampling. We can do disproportionate over sampling. For example, when we understand that a particular subgroup is underrepresented, we can do something called booster sampling. We want to boost that particular thing. And of course, there's a multi-stage sampling of 4 or 5 stages where you apply randomization rule every time. Just to give you an idea, for example, when you start with polling parts, you pick polling parts at random, then you go to households, then you pick households at random, then you go to household members, then you pick household members at random. That's how you ensure randomization at every stage, right? So let's do this on Excel, right? How does this work? I'm just giving a small, brief uh, kind of a workshop on how do we do this. Before I move it to the Excel, is there any particular question, Dr. Kishana, that I need to probably answer? Do you think? Or should I just jump into the Excel right away?
Just let me check.
Yeah.
No, there is no question as such on the
Mhm.
topic. So you can just go ahead with whatever you're doing.
Fantastic. Yeah.
Yeah.
All right. So just again, uh, a housekeeping check. Everybody can see this. See the screen on the right here. Dr. Vishanu, if you can see the Excel sheet
Yes,
on my.
we can. We can.
Okay,
At least I
fantastic.
can. So go ahead.
Yeah, fantastic. Right. Okay. So what do we have here? So I've just created a sample sheet where we have a lot of about from 1 to 1,000 people. Okay. There's 1 to 1,000 people that I've picked up. Suppose this is the population that we have. Okay. And these people are from, say, uh, 1 second. Yeah. Because of this thing. Yeah. So they're from, yeah, here I go. So they're from 4 zones, as you can see: east, north, south, and west. They're from 4 different zones, right? So now, if I really have to pick people at random, how will I do that? Okay. Before I move to stratified sampling, I just want to make sure that I pick people at random. Suppose from 1,000 people, I need to take about 50 people at random. How will I do that? Okay. It's simple. Okay. I just create a column called random. Okay. And I create, uh, I hope everybody here can has a basic understanding of Excel, how Excel works, because when you have to apply a formula, you have to start with an equal to. Okay. I'll say RAND. It says rand, returns a random number greater than or equal to 0 or less than 1. Double click on that. Once you do that, okay, you can see a half of the parenthesis is open. You got to just close that number, parenthesis, and just press enter. You can see a random number got generated in front of person number 1. Okay. Let me do that again for you so that people can understand. I'm going to do RAND. Okay. And close the loop, which is to close the parenthesis manually, and say enter. This way, a random number got generated in front of this person. Okay. Now, if I have to generate a random number, which is generated by Excel, right, which is generated by a machine, okay, I just need to double click on that small dot, which is on the right. You can see this one. When I click that, you can see that every individual right now here has got allocated a random number generated by Excel. Again, as I said, this is done by Excel, does not done by me. So there is no bias involved. It is completely randomized generated number. For example, these people, 1,000 people, are standing on the ground with a placard and with a number which is given to them, completely randomly given to them. Okay, they're now standing on the ground. Okay, so now what should we do? Now, since these people have been standing right on the ground with a number placard in their hands, how should we pull these people or call the 50 people at random? Right? How should we do that? Isn't it? So that we need to work on something called a calling mechanism or a selecting mechanism, right? I don't know whether we can interact with the audience here, right, Dr. Krishano? I don't think so, right? Anybody can, or we can't do that.
No,
Yeah.
I don't think the students can talk, but they can write things on the chat box.
Okay. Is there anyone? I just want to write an open question here. Is there anyone who understands there is a calling rule? If you have to call people who are 1,000 people who are standing with a placard with a number in their hands, which is generated by, for example, say Excel, how would you call people? 50 people at random. Is there any? Just put it on chat. I'm just going to give you a minute. Anybody, feel free. There's no right answer. There's no wrong answer to this, right? So if there's a way that you can just call people at random, you can say number we can give. Oh wow, okay. Now I can see some people are participating. Some people are saying we look up, just randomly call the numbers. But we have already given random numbers, so how can we call random numbers? Uh, right? So there has to be a way to call these people out. How will you pick 50 numbers from these 1,000 random numbers? Okay. Ellie says we look up. I don't think the we look up would work. Yeah, we look up if there are people who have exactly same IDs in a different Excel sheet, if you want to call them. Somebody is said arranged by order. Hakuna. Fantastic. Would you like to elaborate on that? That would be amazing. You're exactly on the right track. How would you arrange them in an order? What order are you talking about? If you can hear me, you're on the right track. This is brilliant. I'm really happy that we are able to at least interact with the audience through chat at least. But okay, let me just pick it from where Hakuna just said. I think standard deviation. Okay, brilliant. Sort by descending order or take the first 10. Fantastic. Let's do that right here. So what you need to do is you just need to select all of them. Okay. Go to home. All right. You just need to pick people. You go to sort and filter. There's something called custom sort over there. Okay. You need to just pick the column number, which is random. Okay. And you can see the order, which is smallest to largest, which is from the small to largest number, which is the ascending order. You can just do that. Say OK, and you can see the entire data set has got shuffled at random. Okay, it means we just found a calling rule that we just shuffle this entire data set in an ascending order, and that way we can just call the first 50 people. Just select the first 50 people, and that will be your people that you're going to work with. Right? That's exactly are your selected sample people. So this is why I wanted to particularly work this exercise in front of you is many people believe that they know how to randomize. Okay. It's not that simple. Once you get the population, has to be a completely unbiased exercise using a software, right? Without any human intervention to that. Okay. What did we do? When we assigned the random numbers, we did not put any human bias to that. Excel generated those random numbers, and everybody had that random number in their hands when they were standing. And they were saying how, then we said, okay, how to call the first 50 people or any 50 people? We just created a calling mechanism, which is this way, or we put an ascending order, and the first 50 people who got selected are the first randomly selected people. Now, this is the simple random method of using Excel. If you, especially when you people are using this data set for policy evidence, particularly for implementation, policy implementation, or monitoring and evaluation that you people are doing. When you people want to do evaluations, you want to put people target group and control group in a random manner. This is exactly how you want to use this data set for. Okay, that's how it will be. Now, if you want to do a stratified sampling, how will you do that? Okay, I'm again, now this is there anyone who wants me to do this again? Just put it on chat. I can do that again. Yeah, you have to unmerge the cells, Abhishek. It won't work with that. Yeah. Hey, Rishabh is saying that I should do it again. Okay. Wait, just all right. I'll just do it one time so that everybody's clear. Right? You select all the data set, right? Go to sort and filter, right? Go to custom sort. Since we are randomizing it by random variable that we created, right? And by default, the order is smallest to largest, we're going to say okay, and that's about it. And you just have to pick 50 people, which is first top 50 people, right? Now the idea is okay, this is your 50 people that you need to work with. Now the idea is simple. If you want to stratify this sample, it means that you want to stratify or pick people up based on the proportions they exist in the population. Now, just a question to the public who is listening to this webinar. What are the four, or what is the stratifying variable that we're using in this data set? Anybody in the chat, if you can answer that. What is the stratifying variable that we're using here? Anyone, feel free. Zone. Thank you so much, Sumalita. Is exactly the zone, right? The region that we have. Fantastic. So now, brilliant. I think all of you got that. So we're going to stratify the entire population into by using this stratifier variable, which is called zone. Okay. But we need to stratify based on how they exist in the population, isn't it? Right. So we need to understand how many people are there of each zone in the population. Since there are 1,000 people, right? How many people are from the north? Let's understand that. Okay. Let's select only north. Okay. We have about 350 people from the north region, right? 350, which is about 35%, right? How many people are there from the east region? East region is about 150, which is about 15% of the total population, right? Now, how many of us are there from south? Let's understand that. We have about 300 people. That's about 30%, right? And that comes to around 70, 80%, right? Towards the last one, which is west, that has to be 20%, right? So this gives me an idea. Sorry. This gives me an idea of how these different regions, sub-regions or sub-zones exist in the population. Like 30% of the total population are north people, 15% are east people, 30% are south, and 20% are from west. Now, how should we go about this? Now I need to make sure that I should, in my sample of say about 100 people that I want to sample, 35% of that sample should be from north, 15% of 100 people should be from east, 30% of that should be from south, and 20% from west. How should we do about it? For example, now my sample is, I should be 35. If I'm sampling about 100 people, 15 people should be from east, 30 people from south, and 20 people from north, from west. Yeah, right? That's the idea. So my total sample size is 100. I need to pick 100 people from these four different stratifying zones. Now, what should I do here? Now, since I have north already selected, okay, I'm going to use exactly the same rule and keep only north selected and use exactly the same logic. Okay, custom sort, random, okay, smallest to largest, and I just going to pick first 35 people. Yeah, which is again got randomized. Right, that's what we're going to do. Now, if you apply the same logic, we just need now select east, which is about 15 people, right? You can see east is still not randomized because we have not selected that. So you go to the same logic, right? Go to the same sort and filter, custom sort, random, it's already there. And we just want to pick the first 15 people, right? And color them up, right? So that way, if you just stop, remove the filter, you can see that in north, these are the people who got selected. In east, if you go just down east, you can see these are the people who got stratifiedly sampled. In a similar way, you can do this for south and west, right? This way, you're able to, divide the population and apply stratified sampling in a, in a randomized manner, but keeping in mind that they exist in the same proportion in the sample the way they represent in the population, right? So that way you can at least use one of the skills of Excel to do sampling, which is I personally feel is something which is very, very relevant, especially in the policy making, especially in the policy analysis. When you people go on the ground, if you want to really understand the impact of policy, right, you got to do this right because this is the basis of the entire evaluation that you're going to do it later, right? So I'm going to stop here because I don't want to overload with too many things. But if there's any question, over to you, Professor Kishanu. This is something which I just wanted to show on Excel since we are already crunch on time. So I want to go more time to the audience if they want to ask any questions. Over to you, Professor Kishanu.
Thank you, Tarun. Audience, please, if you have questions, feel free to write the questions in the chat box so that Professor Tarun can address those. Feel free to ask any type of question on the topic that Professor Tarun just discussed because it was a very deep discussion. And with the questions, he might even delve deeper into it. And that will enrich all our understanding and learning of the entire process of randomization and stratified random sampling. So please feel free to ask questions. Without that, the purpose of this talk will not be fully served. Tarun, while the audience is probably thinking about questions, could you show us this stratified random sampling example once more?
Yes, I'll do that.
Because you showed the regular sampling once,
Yeah,
twice, I think.
yeah,
And if you could, because this stratified thing is a bit more involved, so
right. I'll do
if you
that.
could go through it once
I'll do
more,
that
that would
again.
be great for everybody.
Yeah, I'll do that. Right. So
And
this
then
is
there
how
are some questions which are coming in, which we will address. So,
fantastic. Right. So if you look at this, the data, as I said, when you say stratified sampling, it means that you're dividing the data using a stratifier. And as everybody in the chat rightly said, that we are using a zone or the region as the stratifier for the data stratification. So the idea of stratified sampling is simple, that we use different stratifiers. We understand that how they, how the population is divided into these stratifications. For example, north, east, south, west are four stratifiers. Our population of people that we use in the population is 35% people are from the north region, 15% are from the east, 30% are from the south, and 20% are from the west. Let's understand that. It's something which is very, very simple. If you want to ensure that the same proportion also get represented in the sample, you need to keep in mind that they exist in the same proportion. Okay. For example, if we want to sample 100 people from this 1,000 people, 35 of that 100 should be from north, 15 should be from the east, 30 from the south, and 20 from the west. Right. So they exist in the same proportion of the sample the way they exist in the population. Right. In the sample, there are also 20%. For example, we're taking example of west. In the population, they exist also in 20%. So let's take an example of west here. We need to pick 20 people from the west at random because this is the proportion that they carry in the population, right? So we're going to do this, select again, right? We go to home, we go to sort and filter again, the standard rule, sort by random, smallest to largest, right? And we exactly get this first 20 people that we're going to take, right? And they'll be our people that we're going to use, right? That's exactly how it is, right? And if you remember, if you have to go to again back to north, we wanted to pick 35 people from north, right? Again, if you want to just select them, right? Again, do sort and custom sort, right? Go to random, smallest to largest. Again, just pick first 35 people because they all got randomly shuffled, right? Excel has done that job for us and select. That's it, right? So this is the way you can do it for different regions. And when you've done this for all the four regions, go to data, remove the filter option, and you can see that all of that has already got selected. For example, we have not done this for East again, but West you can see. So same similar way you can see that the people have been selected for all the four regions, and you can do that. Yeah. Hmm. Right. So I'll just stop share here, and if there are questions, Professor Kishore, let me know.
yes, there are already two questions and very interesting questions. The first question is from Hajrat Gul, and that is that what he's asking is the method of selecting the sample actually acceptable? Isn't the sample accepted based on the population?
Is this method of selecting the sample actually acceptable? It is worldwide acceptable, Hazratul, right? If that's the question. Because what did I do? When I said when we selected people from the population, we need to ensure that they represent the population. When I say represent the population, mean in the number, but the kind of variation that exists in the population, the sample should also represent that, right? And this can only happen when everyone in the population has an equal chance of getting selected. Do not put any human bias in selecting people, right? It's always best when we ensure that the software does that job for us rather than humans do that for us. Like you don't randomly assign numbers. Let the software assign those random numbers to those people who are in the population. And that's exactly was step number one that we did. If you look at all the people who are there in the first of 1 to 1000, Excel software allocated a random number generated by the software and they held it. It means that we did not do anything. Completely, the human bias was not there. And when the random numbers got generated, we just used a calling rule. We just sorted them out in an ascending order, and all of them just got randomly shuffled, right? And then we just picked the first 50 or 100 people that we wanted, right? Right? Correct.
Okay.
Yes.
So the second question is from Mohammed Abdullah.
Yeah.
His question is, how does AI affects in the field of data analysis?
Okay. So how does the AI affects the field of data analytics? I mean, AI is all about data. I mean, for example, so this is probably the question that you're asking, and I'm going to answer from a very generic perspective, right? If you're asking about see, data could be quantitative, data could be qualitative. The example which I just gave you is how to use quantitative data, right? Especially the people that you have, number of people, which is in numbers, how you want to pick them up from. But if you're asking me a general question, see, if you're making a policy is backed by data, right? Now, people are using AI tools to actually make policies. How do they use that? Because there is data at the back. The data has to be strong. The data has to be reliable. For example, when I started my talk, I gave you an example of how urban data generally is very weak. People have been collecting data left, right, and center, right? If this the same data which is already available in open data sets, open, which is like, for example, census, NSS, all those things, which are now picked up by AI, if the data itself, remember I started example when the raw lists, right, which is the administrative data, if that data which is feeding the AI software or the raw LLM models that you are working on are itself not reliable, whatever the results that AI is going to produce for policy making is not going to be reliable, right? That's the reason when we heard that when I started my research in urban, this was the first question that we wanted to address: how to fix the urban data, how to fix the weak urban data, right? That's the idea. Literally, you won't believe that we actually went on the ground, we selected our own sampling methodology, and then we collected data on basic service delivery parameters, right? Because we wanted to be absolutely sure that whatever urban data which is coming out on, which is the urban information that is coming out on basic service delivery, a parameter called citizen participation for that matter, all the indicators that we selected, it should be reliable. It can be used by people. It could be, if you want to put it on public domain, nobody should actually question the methodology of it. Even if AI picks it up, AI should be, whatever information that AI generates should be reliable.
Okay, there is another question, and that is from Eli. And the question is there a simple example of using Excel for classification?
Yes, why not? I mean, if you want to classify, I just did that for you. For example, when you want to classify data into different regions. So, for example, in this case, you want to classify data into different demographic categories. Generally, it happens when you have data by gender. Sometimes data you have by different markers like rural, urban. Sometimes you have data by slum, non-slum, right? In this example, which I just took, for example, in this case, right, we have a very clear demographic marker, which is region, right? For the sake of simplicity, I did not pick any other marker. I just have the data by region, right? In this case, right? So I just did that. For example, now if you want to understand a classification, like for example, you want to classify how many people are from North, how many people are from South, because this is the only analysis right now you can do, because this was not the purpose of this exercise. You just wanted to sample. But if you want to just classify, you just quickly pick the number of people here, right? There's something called count if, right? You can use that simple technique and just understand, right? Just select the entire range and just go to whatever category that you want to pick the number for and select say north, right? And this will just give you the number of people. It just says 350, right? So this way, if you want to correct the percentage from that, you just collect that number, divide it by 1,000 because that's the number of population that we have, and multiply it by 100. That's the percentage that you're going to get, 35%, right? So that's the simple classification that you can do in this case because this is the only classification available to us. I hope it was clear. So there's a simple command. Let me do this again for you called count if. It just simply counts the number or frequency of the number of a particular category. It has two things. One is count if. It asks you two things. One is the range. For example, when you selected the range and then criteria. For example, number of people in South, I'll select the South as a criteria and it will give you my number, which is 300 people right here. Yeah, that's it. Yeah.
Okay, there is one more question already. Very
Yeah.
good, fantastic questions are coming in. What is
Mhm.
the question is from Abdul Wahab. What is the best for data analyst, Excel or Python with Panda?
What's the question again? What's the best software?
Yes, the question is basically what is the best software for data analysis? Excel or Python with Panda, Panda library.
Brilliant. Brilliant. Right. Let me just answer this question in a way. Okay. So there are two aspects or two criterias you decide on a particular software. First of all, the organization that you're working in, the kind of software that your organization uses, that's number one criteria. Okay. If your organization itself has subscribed to something called Excel, I mean, they don't have any other subscriptions, right? Of course, even though Python is an open AI software, I completely agree, right? That's number one. For example, my organization where I worked with, they had subscribed to Stata, which I personally feel is very comfortable. I was comfortable with. Number two is what is your skill set? Okay. If your skill set is that you're comfortable with Excel, go with Excel. Nobody's going to judge you that you're just using because at the end of the day, data is data. The results are results. Okay. And if you believe that you are comfortable with Python with Panda, Python with Jupyter, or whatever directory you want to use, go with that. Absolutely fine. If you're comfortable with SPSS, go for it. If you're comfortable with Stata, go for it. Comfortable with eViews, go for it. The point is that it's all about churning the data, narrating stories, generating stories out of the data. But it also depends on whether your company or your organization that you want to work for has subscribed to that particular software. Okay. If they have not, or if the software itself is completely open source, go for it. If you feel comfortable with Panda, Open Python, or any open source data analysis software, go for it. Absolutely, absolutely fine, right? But the idea is that you should be comfortable using that particular data software. Yeah.
So let me add a little bit here.
Yes,
And this
please.
is the exact reason why in our, for example, the online MAPP program that we have this all this scope that on one hand, someone might choose to do a data science pathway, and in that Python is taught. But at the same time, there are some career stack licenses where people can actually do these other softwares through certification from available courses on Coursera. So all of these possibilities are there because ultimately, as Professor Arora has said, these are just tools which we use to do certain things. And some tools are better at other certain things compared to others. For example, a hammer is good at putting nails in something, but a saw is required to cut something into pieces. So, of course, some of these softwares are better than others in certain tasks. But at the end of the day, if we just know one particular thing, we need to know that very well because most of these can do things maybe in a one can do a little bit in a roundabout way compared to another software, but they can achieve all of these things. So let me take the next question, and that is how about the number of people selected? So Tarun, it is about the example that you were using earlier. So the question is how about the number of people selected was selected by you just as an example, or actually that number could be said to be a sample. The
Fantastic.
sample, shouldn't the sample be proportional to the population?
Fantastic. I
Very
think
good
it's
question.
this would require a different sampling class itself. But if I really have to summarize this in a very quick time, so generally there are two parameters. Those who are actually have done some statistical course before or have some understanding with statistics. There are two terms. One is called confidence interval and confidence level. Okay, so there are two. These are the two terms generally used to come up with a sample size. In this exercise, I just took a random sample size example, which is 100. I just took it like completely random. But the point is that if you also need to have a minimum number of people that you need to pick, which so that you can represent the population. There has to be a minimum size, right? And that size comes from two parameters. One is called confidence interval, and one is called confidence level. Now, confidence interval is nothing else but the margin of error. Okay. For example, when you pick sample, right, from population, it's always that there will be some margin of error because we want to use the sample numbers, the people that you've taken from sample, and you want to ask this question, right? And when you ask that question to them, there'll be some difference between the numbers that the sample number will generate and the population. For example, when I ask this question to people who are from sample, that how much did you spend on a food aggregator app in India? We have food aggregator apps like you have Uber Eats. We have something called Swiggy or Zomato. How much on an average per day did you spend on a food aggregator app during pandemic? Okay, how much on an average per day? When I ask this number from the people that I've picked up from sample, and when I ask this number to everybody in the population, there'll be some difference because the population will give me the actual number, but we need this number from the sample. So there'll be some margin of error that we got to keep. Okay. But if I want to keep this margin of error smaller and smaller from 5% to say 1%, I need to go move closer to the population. It means my sample size will become bigger and bigger and become closer to the population itself. Right. So if you want to keep the number which is confidence or level, or sorry, confidence interval to be 5%, which is statistically acceptable. Anything more than that probably is not. But if you want to keep it to 5% and less than say go to 1%, which means that you're moving towards the population itself, right? Generally, in this case, when you use these two terms, confidence level and confidence interval, there are generally a software, open source software called like sample calculators, right? Available online, right? Uh, just want to give you a quick, if you could just share the screen right now in front of you. All of you can see the screen on right now. Okay. I just said, for example, you have a population of 1,000, right? Uh, sorry, 1,000, right? Let it be by default. If you want to take the margin of error of say 5% and confidence level to be 95%, you can just calculate the sample size, right? Which is exactly called 278, right? This is the exactly two parameters that you use, and you use any open source sample calculator, and this will give you the sample size that you need to use. So to answer your question, I took 100 as just a complete as an example. But if you want to use generate a proper sample size that you need to represent the population, for example, population size of 1,000, you just use these two terms, confidence level and confidence interval, key in those figures, and you will be able to get that number that you need to use for your sample.
There is one more question, and that is actually there are two questions already.
Mhm.
Uh, One is, can we use pivot table as a tool for classification in Excel?
Fantastic question. I couldn't agree more. That's the answer I can say. I think pivot table is a great way of classification, right? If I could just use this right now in front of you, that would be great. Uh, I think these are all great questions, Professor Krishano. I think these people are asking exactly the kind of question which any data person get excited about, right? So let me just remove everything here that I've done so far. Okay, let's go back to basic, right? For example, if you want to select this data, go to home, insert. Can you see on the top left is something called pivot table, right? And from table, it will just select exactly the table range which is by default available. And you would select that you want this pivot table to be the new worksheet. Why not? Right? go for it. You just want to understand from each zone how many people are there, right? You create zone, put this zone into this 4 by 4 matrix that you have, put them into zone which is rows, put them into values, and you can exactly get the same number that you want, right? The best way to classify in just like a snapshot. Okay. Like for example, on the top or the bottom right, which is said the sigma, which is like a values thing, it will give you the count of all the 4 categories that is there in our data set. One of the easiest way to classify your data. But if you want something else, right, you go to value fold settings, right? If you want, say, average, you can just, or probably sum, you can change that category and it will give you exactly that, right? That's how it is. But right now we just stick to count. But thank you so much for asking this question. Of course, there's so much that you can do on Excel, right? But since we had limited time, I just wanted to focus a little bit on sampling. But thanks to the questions, I'm able to demonstrate some little more on pivot table as well.
I think we have only time for one more question, and it is already here. The question is, can Excel be used for Bayesian classification, that is predicting labels? Would other software be preferable?
Now, for anything which is Bayesian analysis or probability, if you want to use probability distribution curves, I mean, a basic analysis can be done on Excel, but I would really suggest that you use something which is more advanced than that, right? As of now, right? If you did all Bayesian probability distribution curves or any for a probability distribution curve for that matter, I suggest you go for Stata. But if you stick to, I think Professor Krishan just correct me. I think Python also can do that for us,
Yes,
right?
Python or
So everybody can do
any
that.
proper statistical software and
Software
statistical computing environment can do that.
can do that for us. Yes, absolutely. But not Excel at this point. Yes. You can do simple statistical hypothesis testing like RT tests and all that here. Uh, but if you want to really go deeper into analysis, statistical analysis, I think you probably have to move to a better, more advanced softwares. Yes.
Maybe the advanced add-ons to Excel
And
or
also that
Power
can do
BI,
a little
these
bit
things can
F
do
test,
it,
T tests.
but for
Yes.
any proper statistical analysis, at least in my opinion,
Yes.
a full-fledged statistical
Statistical software
software
is required.
is better.
Yes. 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 Yes.
Okay, so let us just
Great.
see if there is any more question. There is none. We are almost, hold on, there may be one more. Okay, there is one more question. I think that is the last question that we can take because this is actually a very interesting question. That's why I can't leave without addressing this. Tarun, the question
Yes.
is, some people take p-value to be 0.005.
Right.
For some, it is calculated, which is proper. Um, so I think uh, just go ahead and this is the
I think
last question that we can take. Um,
it's a fantastic question. I think you just questioned the entire statistical way of doing things. I think first of all, let's understand what is this p-value that we talk about, isn't it? The p. Let me just go into a little bit of statistics if that's okay. Right. So generally, when we do hypothesis testing, right, there are usually 2 types of errors that we commit: type 1 and type 2. Right. And the type 1 error is, of course, when your null hypothesis is true and you rejected that, isn't it? And type 2 is when your alternate is true and you still don't accept it, right? That's the 2 errors that generally people commit. Your p-value, okay, which is also called the level of significance, okay? I mean, I'm just going to ask in the chat, which one do you think is this error represents? Type 1 error or type 2 error? Anyone? Those have done statistics a little bit. Which error does this level of significance or probability value that the person has asked is represent? Or let me ask you a generic question. Which error is more important to contain? Which is type 1 error when you are innocent and you've been rejected, like a null hypothesis, poor null hypothesis, when it was absolutely innocent, it got rejected. And or the type 2 error, which was when the alternate hypothesis was true and we did not accept it. I mean, it was guilty, but we did not, we just let it go. Right. So the point is like that. So which one do you think? Accepting a false one is dangerous, right? Or you think that accepting the false one is dangerous rather than letting the honest one, like for example, when we reject the honest hypothesis, when we put the innocent one behind bars, is that more dangerous or letting the guilty go? Would that which
the
do you
answer
think is
is the answer here from Sumalatha is accepting false one is more dangerous.
okay? Right. So the more dangerous the statistical people believe is that the innocent should not be framed. Innocent should not become guilty. Like the error is that when the null hypothesis is true, when it is innocent, it should not be rejected. And that level of significance that you just talked about of 0.005 is actually the possibility of that error. So we believe that we should be containing that error very, very clearly. And that's what we call level of significance. Generally, people believe that even this level of significance can also go up to 10% also. Not a problem these days. It's acceptable, right? But not beyond 10%. Because there's a high possibility that even though your best analysis, that you can end up rejecting the null hypothesis, even though it was true. And usually in research, people believe that they should reject null and prove the alternate hypothesis, which they believe as true. Right? That's how it is. So my question to you, or my answer to you is that 0.05, the 0.05, the probability of 5% that is given is something which is statistically given, which is acceptable. Even 10% is acceptable, but I would suggest that to keep it to 5%. Yes. Professor Karan, if you want to add to that, please go ahead.
No, no, I'm just trying to say that we are almost out of time. And this was a very informative session on Excel to evidence, on statistics, on sampling. I learned a lot from this session. There were many things that were completely new to me, and I'm pretty sure all the people in the audience and the participants learned something new today as well. Dr. Arora took us over the entire process of randomization and random selection. He also discussed stratified random sampling and taught us how to actually do it in Excel. It was a fantastic session. Thank you, Professor Arora. And
Thank you, Professor Karan.
thank you to all the participants, some of whom I'm pretty sure woke up very early in the morning from the other side of the globe. For some, it must have been a very long day because night is falling on some other part of the globe. So thank you for joining this session from wherever you are joining. I'm pretty sure this was worth your time. And thank you for the Coursera team who were there to handle any problem that we might have faced during the session, but there were no issues. This went very smoothly for the due to the efforts of the Coursera team. So thank you, team. Thank you very much, and thank you, Professor Arora, for your time. Thank you, everyone. So
And thank you, Professor Kishana, for moderating it beautifully, as the way you always do.
thank
Thank you
you,
so much. Yes.
and let's call it a day, and hope to see you, some of you, in the future sessions as well.
Thank you so much. Take your time.